Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we dive deep into understanding of curl of a vector point function, how it is calculated using the determinant form and how it represents rotation or circulation in a field. Okay. So here, I'm going to explain the formula step by step and relate it to the real life phenomena like water, whirlpools, tornadoes and magnetic fields. Okay. So the formula here, we can start with a vector field. Okay. Vector field f₁𝐢 plus f₂𝐤 plus f₃𝐤. The curl of this field is denoted by curl f, vector f. Okay, that is denoted by del cross vector f. Okay, and is represented in the form of determinant like this. So here del we can write it as I times dou by dou x plus j times dou by dou y plus k times dou by dou z crossed with vector f, that is field vector f₁𝐢 plus f₂𝐤 plus f₃𝐤. Okay, now in the determinant form we can write the unit vectors here and all the partial differentiation, and then we have the unit vectors here too, right? So unit vectors, then this in one row and the other function f₁, f₂, f₃ in the other rows. I hope I'm clear. So I'm just writing the summation wherein I multiplied with here the determinant, if I'm gonna find for I, dou by dou y f₃. So partial differentiation of f₃ with respect to y minus partial differentiation of f₂ with respect to z into I. Okay, so expanding the determinants, this is a summation I have written. I can also show you the expansion, but before that, note curl of a vector point function is a vector quantity. Curl of a vector point function is a vector quantity. Now expanding the determinants, I'll just write it here. Expanding the determinants gives I like to use different colors of pen, so let me just use the red pen. Here I have like dou f₃ by dou y minus dou f₂ by dou z unit vector I minus dou f₃ by dou x minus dou f₁ by dou z unit vector j plus dou f₂ by dou x minus dou f₁ by dou y into unit vector k. I hope you know the expansion of the determinant to find to find the determinant. I hope you know that. If you don't know, just put it in the comment section. I'll just bring out one more video for you guys. Okay, so this is a final vector, points in the direction of axis of rotation, and its magnitude tells us how intense the rotation is at that particular point. And when I talk about the real life example, okay, consider water in a sink. You have a sink at your home, right? Wash basin or anything. So when it completely or partially gets filled, and consider something is stuck into the hole from where the water passes to the gutter or wherever. So something is stuck there, and if you remove that piece of paper or whatever, so water starts curling like this. Whirlpool, it makes some kind of a whirlpool, right? It exhibits a curl. So the water particles rotate around a center point. So consider this is the point from where the water has to pass, right? The water passage, from here the water has to pass. So consider this is the water, this is making this kind of a rotation. You can see some sort of a curls there. Tornadoes. So air rotating around the central axis in a cyclone or tornado is a powerful example of a curl in action. Okay. Now we also have the electromagnetic fields. So the changing electric fields can induce magnetic fields with a circular curl-like patterns that is at the heart of the Maxwell's equations, if you know that. Okay. So if you like the explanation, if you like the video, do not forget to subscribe to my channel, hit the bell icon, follow me, share it with your friends, like, and do as much as you can help me. Do the minimum for helping me. Okay. Thank you so much.